Okay, let's have a try at view update. So you convince the reindeer to bring you the page. The page confirms that your hash algorithm is working. The book goes on to describe a series of boxes 0 through to 5. Boxes are arranged in a line starting from the point where the light enters the boxes have holes that allow light next or line. Inside each box there are several lens slots that will keep a lens correctly positioned to focus light on the box. The side of each box has a panel that opens to allow you to insert or remove lenses as necessary. Along the wall running parallel to the box is a large library containing lenses organized by focal length ranging from 1 through 9. The reindeer also brings you a small handheld label printer. The book goes on to explain how to perform each step in the initialization sequence. The process it calls the Holiday ASCII String Help Arrangement Procedure, HashMap for short. Each step begins with a sequence of letters that indicate the label of the lens on which the step operates. The result of running the hash algorithm label indicates the correct box for that step. The label will be immediately followed by a character that indicates the operation to perform, either an equal sign or a dash. If the operation character is a dash, go to the relevant box and remove the lens with the given label if it is present in the box. Then move any remaining lenses as far forward in the box as they can go without changing their order, filling any space made by removing the indicated lens. If no lens in that box has the given label, nothing happens. Okay, if the operation character is an equal sign, it will be followed by a number indicating the focal length of the lens that needs to go into the relevant box. Be sure to use a label maker to mark the lens with the label given in the beginning of the step so that you can find it later. There are two possible situations. If there is already a lens in the box with the same label, place the old lens with the new lens. Remove the old lens and put the new lens in its place, not moving any other lenses in the box. If there is not already a lens in the box with the same label, add the lens to the box immediately behind any lenses already in the box. Don't move any of the other lenses when you do this. Okay, so we just push to the end of a vector. If there aren't any lenses in the box, the new lens goes all the way to the front of the box. Okay, so if the vector is empty, we create a new one. Here is the content of every box after each step in the example. Okay, Rn equals 1. So Rn would give us a specific box. So this is like the label that we're going to get the hash of. In this case, it returns box 0. And then we add a lens with label Rn and what is it? The focal length 1. Then we get Cm minus. So we find Cm and we remove it, but there isn't any, so nothing happens. Then Qp equals 3. So Qp obviously goes to box 1, and then we add focal length 3. And Cm equals 2. The Cm is obviously the same box as Rn. So we add it to the end and focal length 2. And then Qp minus. Let's just remove this one. Pc equals 4. Goes to box 3. Add focal length 4. Etc. 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 Okay, so after the last OT equals 7, we'll end up with this. Okay, all 256 boxes are always present. Only the boxes that contain any lenses are shown here. Within each box, lenses are listed from front to back. Each lens is shown as its label and focal length in square brackets. To confirm that all the lenses are installed correctly, add up the focusing power of all the lenses. Focusing power of a single lens is a result of multiplying together 1 plus the box number of the lens in question, the slot number of the lens within the box, 1 for the first lens, 2 for the second lens, and so on, and the focal length of the lens. So we get Rn1, box 0, first slot, focal length 1. Okay, We add all those together, get 145. Okay, let's get started. I think for the first thing is we want to make sure that we want to change the way we pass to store the focal length of the lens and everything, I think. And maybe we just create something new. If we have a lens has a focal length and a label and we have an enum instruction we'll call it add and remove. Okay. Okay, we want to start with a boxes is going to be 255 boxes, and each box be a vector of lens. That's its type. A vec. I'm doing something wrong here. It's a vector of vec. Okay, so lens needs to be clone. On. Okay, so we've got our boxes. Okay, and then for each step, okay, and the step will be something like this. Hmm. I might split. Yep, let's split. Dash. Split. That maybe. Let me chuck 0 in here. Right. Yeah. See? I have some strings that contain some letters followed by either a minus or an equals, only by a number. I want to split this into string instruction number this side. Instruction is an enum that will either be add or remove. I don't want to use regular expressions because they suck. Okay, so this instruction. Okay. Make this instruction type struct instruction contain the label followed by instruction type followed by the length. Option is can implement from stir or instruction. Okay. Now, either equals label and string new. Okay, I'm going to loop. So we say while let some char equals iter next. Okay, we'll start with the instruction type of length equals Okay, so I'm going to loop through the iterators, and I'm going to match on C. C is either going to be a character, it's going to be dash, equals nine. It'll actually only be 1 to 9. Equals thing. Plus, copy, paste. Okay, we take while we got digits. Select it into a string. Put a numstr. Size. Focal length. That. You need one more. Type. Be everything else. Push that string. Table. Push. Give us an instruction. Loop through each step. Get step.pass. Okay, let yep. Okay, we have match on type. Get the instruction. Okay, we got very specific things. this. Okay, equals. Okay. Okay, so we have to check the box for one with a given label. I don't think we should check hash map. Hash. Lens. No, they gotta be in order. Okay, so if we get instruction dot label, get hash, let hash equals. That's the box we need to check. So we go boxes hash dot contains this size. Contains lens. Find lens dot label equal instruction dot label. Okay, option. Oh, this. Okay, if let sum x sum lens Okay, so we find a lens. If there was already a lens, we have to replace it, right? Change the, I think we just modify it. Lens, meter mute. And then we can say lens dot, so we can dereference it, lens dot focal length equal instruction dot focal length. We dereference. Sum instruction dot focal length Right, now if focal length equals instruction focal length, that's right. If that's right, if that. Okay, so we're going to update it if found. It's not in there. We add it to the end of the vector. We go boxes hash insert new lens. Label is label.clone and focal length. We can collapse this. Push. We need to push. Okay, do that. There we go. Okay, so we're going to add to the box. Okay, now we've got to handle removing an item from. Okay, we find it and remove it. Okay, here we go. Hash is going to be the same regardless. So if we move that out here, and we say boxes hash iterate filter remove boxes hash dot and index on position maybe. Yeah, okay, if I find the position, that's going to let index equals find position, going to be lens.label equals instruction label. If let sum index index and lens okay. We got destructural like that. Okay, we get index lens, and then we do boxes hash remove at index. We don't need this. Okay, so by the time I get here, boxes should be full stuff. So then we need to get the score, which is the calculation. Okay. Box number. Okay. Okay, let's loop through the boxes now. So we're going to go for O I in O dot dot 256. Let total int total equals 0. I'm going to return total. Okay, we're going to loop through the for j in boxes I dot len we get the value of each one. So we're going to get the focal length. So boxes I j is this a lens. Lens needs to be clone. Oh, you can't copy a string. Okay, we get the lens, and then we got the focal length. Times slot. Slot will be j plus 1. Box number. And then we're going to sum them all together. So we're going to total plus equals that. We're going to do a I64. As I64. As I64. As I. Oh. Loop variable I is never used to index. It is though. Leave it like that if we get the right answer. See cargo run. We got an answer. 221627. There we got it. Here we go. Let's see if we can improve this a little bit. So let's consider using an iterator. We go boxes. Enumerate. No, I'm gonna leave it as is. Let's stick with that. Let me do our test. So our test. Day 15. This up with 145. Passes. Okay, let's get rid of the stuff we didn't. Okay, okay, add and remove should be uppercase. Two. Remove. Okay, we didn't end up using a hash map. That. Okay, this can also be is digit, is ASCII digit, is ASCII digit. That. Okay, let's go boxes dot iter dot enumerate. Okay, we get the usize plans. Okay. We get the what do we get? We get the lenses. We get the index, and then we get the lenses. Okay, and then instead of I, we use index. Lenses. Lenses. We use index here. Do the same thing here. And we go lenses.iter.enumerate for each. And we go okay, lens. Okay, we're going to get rid of this. We're going to put I. Do that to here. Okay, so I'm going to have lens. Get rid of that. And index is the I. Okay. Boom. That's much cleaner. And let's try that. Nice, 200 less than a millisecond, 0.2 of a millisecond. Take it. No, git add dot. Completed day 2. Completed day 15, part 2. Cool. I'll see you guys for day 16.